once you take 10 records and turn them into 50,000 records, there are a bunch of privacy risks that come from, just manipulating the statistical properties in that way. So you can see, sort of audience-based, what kinds of people are purchasing what kinds of items at some big retailer or something like that. But you actually do need a pseudonym if you want to tie into the major online ad networks. Clean rooms solve privacy via secrecy, right? The identities of the people on the other side remain secret. And synthetic data solves it through anonymity, which means you can see all of that granular data, but you can't actually re-identify who the people are. And so those two things are really powerful in a sort of standardized workflow. The ability to inject noise computationally may turn out to be very, very, very valuable in anonymizing unstructured data.
Hello everyone, I am Sergio Maldonado and this is Masters of Privacy, a set of interviews covering the intersection of marketing, data, privacy and technology with a clear goal in mind, which is redefining the relationship between people, brands and media around transparency and control. Which is to say, we're aiming for real customer centricity, or if you will, human centricity. We regularly talk to DPOs, CMOs, CDOs, and whoever else we find interesting and able to share valuable insights. So we hope you like it. Please do reach out if you have any ideas on future topics or speakers. Okay, we've got Ben Winokur here today. He is the co-founder and CEO of Subsalt, which is a leading platform to generate and work with anonymous synthetic data. Prior to Subsalt, Ben worked in a variety of legal, product and operational roles at Passport, where he first encountered the problem Subsalt solves, which is the fact that privacy and security risks have made it too expensive and hard to access, share and analyze sensitive private data. We will address the value of AI-generated synthetic data not only in terms of anonymizing data, but also in terms of enhancing privacy even when we cannot reach that higher threshold of true anonymity. We will also discuss the interplay between synthetic data and cleanrooms or data cleanrooms in MarTech or AdTech, and the potential value of differential privacy when it comes to onboarding unstructured data for large language model training purposes. Let's go for it. Ben, thanks for joining me.
Thank you for having me.
What's anonymized data?
Yeah, that's a really interesting question that I think you have to tackle probably from two angles. One is sort of technical angle. So technically, can data be re-identified, or can you tell who this data was about? And that's a matter of statistical evaluation, understanding the specific context and shape and all the characteristics of the data. And then there's also a legal question. So anonymous data is exempt. It's this special category of data that is exempt from all of the privacy laws that cover personally identifiable information. And so the real opportunity and the thing that's most difficult about anonymization is aligning the legal concept of anonymization to the technical concept of anonymization. And where do those things meet and where do they disconnect? And that's something we spend tons of time thinking about.
So good. Yeah, speaking of alignment, so in the EU, I come with an EU perspective. So there's been so many court cases coming in both directions, right? And then everyone has an opinion. The last CJ EU court case that I retained as a good clue towards finding out what's anonymous, and that's what I'm using these days as a threshold, is that if the party, the data controller, in charge of processing that data, has a way to get back to the individual, as you were saying, because you may be having a data set that someone may be able to deduplicate or turn it back into, personal data. But if you do not have the keys or you have no way of overlaying additional data sets to bring it back to life, then to you it is anonymous. And to others who are keeping keys and data separate, it may be pseudonymized data because they're able to bring it back to life, but they're keeping it separate as per the GDPR definition. So I think we agree on the legal term, and then hopefully we can make it coincide with the technical term. Because the one thing I keep hearing is that you never know what's going to become available tomorrow in a census data or whatever is leaked or whatever is made.
Or a data breach. Yeah, exactly.
Or a data breach. Okay, so then we want to get to that. And is synthetic data a good tool for this?
Yeah, that's a great question. Synthetic data is a really useful tool for this, but it's not a silver bullet, right? So you can kind of think of some of the risks that you just described. One is you might have a persistent identifier. And so there's real risk in that ID being mapped back to a table that contains a bunch of other sensitive information. But it might be the case that you can re-identify data even without actually accessing the information in that other database. And so, the data itself may be highly re-identifiable, in which case it's not anonymous, even if you don't have access to the sort of mapping table to PII. So a good example of this is I live in Charlotte, North Carolina. That's where we ran into each other most recently. And there are probably like 5 people in Charlotte, North Carolina who are 7 feet tall. If you have a data set with one of those 5 people and you know what zip code they live in, with very little additional information, you'll be able to re-identify them. And so there's a real risk, even where you're transforming data. If you're saying, he's not 7 feet tall, he's 6'11" or taller, or he's not 31 years old, he's 30 to 35 years old. It may not be always possible to actually protect small populations via those techniques where you're transforming real data. The promise of synthetic data is that you can create a totally fictional population that shares the statistical properties of the underlying population, but the individual records don't map back one-to-one to real people, right? So you have these totally fictional patients, and there might be a 7-foot person in that, but that person might be a different age, or they might live in a different zip code, but statistically, they fit into the sort of source population. And so by using data that is not real data, you achieve a higher sort of baseline level of re-identification protection. And then the question is, all right, but what are the tail risks, right? It may be just unacceptable to have a 7-foot person in the synthetic data set because there are so few of them. And so...
Yeah, it's too much of an outlier.
Exactly. And so we do see examples where people say, oh, it's synthetic, so it must be anonymous. And that's not the right way to think about it. Synthetic data raises the baseline privacy protection, but you still do need to do rigorous sort of statistical, technical, quantitative analysis to determine whether that synthetic data can be used to re-identify individuals. And so we think of sort of synthetic data as the baseline technique, and then we complement that with rigorous evaluation of the privacy risks and then mitigate those so that we can achieve anonymity through synthetic data. But I think it is really important to say synthetic data is not automatically anonymous, even though the people are fictional. It can be used to attack the privacy of real people in the sort of training set.
Before going deeper into use of synthetic data, even if you do not accomplish that, and not everybody thinks it's anonymous, you've already accomplished one goal, which is that at the very least, you've pseudonymized the data. You already have introduced a safeguard. So perhaps that's the goal.
Yeah, well, and in a lot of cases, even the sort of we don't preserve pseudonyms, right? Because the people in our population don't exist in the real world. So it doesn't make sense to take a unique ID and join that record to any other record because that record doesn't exist anywhere else. And so it is, at a minimum, it provides a very strong baseline level of protection. I don't know that it's exactly pseudonymous, but it is certainly heavily transformed data in a way that is privacy protective, even if it doesn't get you all the way to anonymity.
Yeah, that's very good. In terms of privacy engineering, we talk of many methods of de-identifying data as a safeguard. If a data protection authority comes knocking on the door, any enforcement body comes knocking on the door, you are proving that you're taking measures to get farther from individuals, even though the legal framework will be applicable to you. So you will have to actually, respect those rights and go through the whole, list of homework duties. But yeah, but you're better off. Okay, so then going into that specific thing, so synthetic data. Although I am understanding now that also, of course, there's that broader statistical analysis and there's an element of introducing noise wherever needed to, again, to be able to get to that level of protection. So within synthetic data, do you see the risk that I keep hearing about? Right, we were at Pepper at that event in Santa Clara in the summer, privacy engineering event, and I heard some criticism of synthetic data. And always the same idea that because it was built on a model that you don't know what's in the model, so that we're being sold something that will be compensating for bias, for example, because you can correct those, right, those sort of correct the imbalance in terms of the data set and how much it's representing a particular group or whatever. But if the model that you're using to generate that data was already biased, you're dragging that additional bias, and the same happens with copyright infringement and with whatever is embedded. What would be your answer to that?
Yeah, it sounds like you were hanging out with some differential privacy people.
Exactly. You got it.
Every time I hang out with differential privacy people, I hear how synthetic data is no good. These are all really good points. So one thing I'd say is synthetic data has been used as sort of a catch-all term for actually several different use cases and problems. So one of those problems is like test data management. I don't think that's what you're talking about, but can you create lower environments that don't contain any production data as a security control? That's sort of use case one. We'll put that one to the side because that exists sort of in the application testing stack rather than the sort of data science machine learning stack. So then you get into the sort of version of synthetic data that applies and where privacy is really important. And there's two distinct use cases to your point. One is you can use synthetic data to fix data quality problems. And those data quality problems might be that the data set was biased. It might be that the data set isn't large enough or diverse enough to train a model. It may be imbalanced. You may have big class imbalances, right? So if you're trying to detect fraud, only 0.1% of transactions are fraud. But like a really, really good performing model will just guess that it's not fraud because 99.9% of transactions are not fraud. So you need to rebalance and say, like, we need to create a bunch of synthetic fraud so that the model can't just randomly guess that it's not fraud. So that's one use case. And that's the use case where what you're doing is you're actually changing distributions from your underlying source data to produce a data set that will work better or perform better along some axis for a machine learning task, as an example. My understanding is that it is sort of beyond the state of the art to both arbitrarily change the distributions from a data set and guarantee privacy, right? That once you take 10 records and turn them into 50,000 records, there are a bunch of privacy risks that come from, just manipulating the statistical properties in that way. Um, and so those are actually not privacy use cases. It's not right to think of synthetic data as a privacy enhancing technology in those contexts. And that accounts for really a lot of the use of synthetic data today. The second bucket, and where we spend our time at Subsalt, is in reproducing data sets with maximum fidelity to the original data set, but while minimizing re-identification risk. So really treating that as a privacy problem, being really rigorous about the analysis and structured about the analysis, because we are not adjusting distributions. We are not creating a lot of records where there used to be just a few.
Very good.
We are not creating 150 7-foot tall people in Charlotte for the purposes of making sure the model accounts for them correctly. And so a lot of the criticism, there's some amount of truth in it, in that synthetic data is not a silver bullet. But if you are going to focus on privacy use cases, a lot of the sort of other synthetic data work doesn't fit into that bucket and doesn't lend itself to the kind of rigorous privacy analysis that needs to be done if you're using it as an anonymizing technology.
Very good. We're oversimplifying, putting it all in one bucket. Thank you. Thank you. Very good. That helps. Good. So then, what's the impact then of you being in the market, or people being able to do synthetic data, being in the market, in terms of democratizing the space? There's plenty of talk that there's only going to be a few players in the game at a certain layer. And one of the reasons why is that we run out of data. Well, first, compute and the money that it costs to train the models. Then secondly, the fact that we're running out of data, and also the data that has been used so far, now it's being scrutinized. It wasn't scrutinized at the outset. So whoever comes on board now, they're subject to all of these legal frameworks. For starters, all the EU AI Act and whatever comes next in California and Colorado and whatnot. So what do you think is the impact? Do you see, I'm being hopeful maybe, that maybe startups and other companies, thanks to synthetic data, will be able to go farther, and then we can level the playing field, or not?
That's an interesting question. I think I'm a little bit skeptical that this is going to lead to a big leveling of the playing field. I do think it has the potential to dramatically increase the quality of the models that are coming out of these few foundation model providers. So right now, all of these model providers are training on mostly the same data, not entirely the same data, but huge corpuses of this training data are common to all of the models. And there is some skepticism that we will reach a ceiling on model performance until we increase the sort of diversity of the training data. The problem is that we've now hit something close to the limit of publicly available data, which means that all of the data diversity that comes from here forward comes from unlocking data that today is sensitive, that is private, maybe proprietary, and is inside of companies. Now, the question then becomes not just how do they legally do this from a privacy perspective, but how do they protect against the commercial risk of their data making it into these models. And the reason I say that I think it's unlikely that this leads to a big democratization is I think one of the things that's going to happen is that a market is going to emerge for these large model providers to actually buy access to this data, to license it. I think that like sort of becomes a feedback loop where being more highly capitalized is actually the solution to increasing data diversity. So it may actually be a sort of thing that boxes out startups actively. But I think synthetic data has tremendous potential so that you can share the sort of statistical properties of more diverse data sets without sharing really sensitive and proprietary commercial secrets or information about who specifically the customer was, all of these things. I think anonymization through synthetic data is going to unlock the commercialization of the next sort of step function change in the data diversity and data quality of the input data to these large foundation models. The one thing I'll say is that today Subsalt works exclusively with structured tabular data. And most of the gains in the sort of LLM world are going to come from unstructured or multimodal data. So text, images, PDFs, or some combination of all of those with tabular data. So while we are excited about the potential, it's not a use case or area where we spend a ton of time today.
I think I read that Llama 3 was, to a certain extent, trained on some synthetic data from Llama 2. So, and back when these models were trained, nobody cared about copyright. I keep thinking about this. I don't know why copyright is stuck in my head, because now I see all the deals, and you were saying OpenAI is signing these deals, probably expensive deals with Axel Springer and New York
Yep.
Times. No, New York Times, they're suing them, right? I don't know, whatever. They're either being sued or paying out, whatever.
They're trying to get access to it. Reddit's another one. Reddit is a huge corpus of
True.
data
Google.
that Reddit has made non-scrapable. And so now they're actively sort of licensing that data.
Okay, good. So have you faced, are you mostly working in the financial sector where it's highly regulated? So I see a very strong business case for that. So I cannot tap into financial data because it is sensitive. And in the US, it's even a sensitive data category, as it is not in the EU, for example. But you can then do more things with that data. Or have you explored the scenario for advertising?
Yeah, that's a really good question. So actually, most of our work today is in healthcare in the US. And the reason for that is that there are large mature markets for the exchange of de-identified health data because HIPAA is so mature, right? HIPAA, which in a lot of ways is similar in structure to a lot of these modern data protection laws, except it's 20 years older or 30 years older. And what happened was de-identification became a really important path for organizations to share and collaborate and commercialize their data. And so that market is mature and has been building for a long time. And in healthcare, synthetic data is a novel technique to do de-identification at scale and fit into existing workflows and data exchanges. Financial services doesn't have, so Gramm-Leach-Bliley, which is the sort of federal law around banking data, doesn't have an explicit carve out for de-identified or anonymized data. And so that market is a little bit less mature, but the sort of market to secure data in compliance with Gramm-Leach-Bliley is very, very mature. So in financial services, synthetic data tends to be seen as a data security technology rather than as a sort of data collaboration technology. So that's where we see most of the kind of focus today. We don't do a lot in marketing and advertising, and it's because the patients in our population or the users in our population don't exist. You can't use this data to target individuals. You can do a lot of really great statistical modeling. So you can see, sort of audience-based, what kinds of people are purchasing what kinds of items at some big retailer or something like that. But you actually do need a pseudonym if you want to tie into the major online ad networks. And those pseudonyms just aren't preserved in a synthetic data set. And so we actually don't fit in, for the most part, into those online advertising use cases. There's, synthetic data may be valuable at the margins of those, but you can't actually do most of the work, the really critical work on synthetics in the way that you can for research or data collaboration or commercialization use cases.
Yeah, that's what I was thinking. We have discussed data clean rooms here a lot. So data collaboration between publishers and advertisers where they can share their audiences. And up to now, there were a lot of people thinking that by hashing for example, email addresses or phone numbers, and then deduplicating that they were not using any kind of personal data until the FTC then came up, in the summer, this summer, and said, no, hashing does not anonymize the data. And so when you collaborate, then you need to probably get consent or find some other, well, there's no legal basis in the US, but something along these lines. But I was thinking that both, again, no matter the jurisdiction, you could use this to go farther. If I cannot collaborate with the actual data, and I do not want to be, looking at consent, which means the audience and the sample size is going to be very small. So I don't know if it's going to have any significance when you start then targeting that audience elsewhere. If instead I could just simply accept that I won't be able to work with 10% of my audience, why not build in a synthetic data set which could represent 100% and it's maybe more accurate or works better than a 10% of the actual audience? I wonder whether someone is playing with that. It's something that would be so interesting.
Yeah. So clean rooms and synthetic data are unbelievably complementary, right? Um, this is something we run into a lot, actually, is that clean rooms generally preserve privacy by aggregation, right? You can ask how many users fit into this set of characteristics, or how many people in your data set are 35-year-old women who own a metal water bottle. I'm just thinking about a thing. My wife loves her metal water bottles. But you can do those kinds of generalized queries in a clean room and get answers back. The problem is that's actually a pretty hard way to do exploratory work. You're actually looking for the signal, but it's hard to do a lot of times in a clean room environment where you can't actually look at individual rows of data and look for patterns and do that exploratory work. So one pattern we see a lot is an organization who has set up a clean room. They want to do data collaboration. They may share a synthetic version that is anonymous of their patient population to the other party, which helps them write the maximally productive queries in the clean room without ever having to see any real data. So they get the counts they really care about. They can determine their cohort definition or targeting criteria in the clean room or on the synthetics, and then bring that analysis to the clean room to run privately. So they solve just two totally separate problems. Clean rooms solve privacy via secrecy, right? The identities of the people on the other side remain secret. And synthetic data solves it through anonymity, which means you can see all of that granular data, but you can't actually re-identify who the people are. And so those two things are really powerful in a sort of standardized workflow to start on synthetics, finish in a clean room, and preserve privacy throughout the whole life cycle.
Okay, a last question. So then moving forward into what's coming next, right? Where you see, because you see much more than wherever I could see. So what's around the corner as the next frontier? If you're only looking at healthcare data, maybe we can look at that. If you can think, with a broader view in terms of everything we could be doing in the future, thanks to synthetic data with AI. And I am now coming at it from the AI governance point of view, so that we can be more transparent, so that we know how to trace that data. So with everything that we are being asked to do, which we weren't asked to do 2 years ago, now we have to do all of this, the AI policy, transparency, fairness. There's so much stuff. So what do you see coming around the corner as the next sort of big thing?
That's a really interesting question. I have kind of two answers. The first one is from a technical perspective. Anonymizing unstructured data is going to be very important. And I'm not aware of anybody who's able to make rigorous anonymization guarantees on unstructured data. That data is so multifaceted. There are so many possible angles of re-identification attacks that a human could do on an image of a person walking down the street, that blurring their face may do nothing if you have a timestamp of when that picture was taken, or any number of other things. So the first thing is figuring out a like really rigorous way to anonymize unstructured data. And this is a place where differential privacy may turn out to be, this may be the killer use case for differential privacy, is that noise injection, the ability to inject noise computationally, may turn out to be very, very, very valuable in anonymizing unstructured data. But I think to this point, it remains an open question how you are going to take 30 years of support tickets and make sure that they are sufficiently anonymized that you can license them to OpenAI or Google or Microsoft or whoever. That remains, I think, a mostly unsolved technical task that will have to be solved, whether by synthetic data or differential privacy or some other method, in order for that market for data to emerge. So that's one. The second actually kind of touches on what we just talked about between synthetic data and clean rooms. And I think that there is a need for a platform to emerge that standardizes these sort of workflows that require multiple privacy enhancing technologies. How do you get from idea to execution while having a strongly documented, standardized workflow of how data moves from phase to phase of that project? So there's an exploratory phase, there's a computation phase, in some cases there's also an inference phase. How do you chain together the various privacy enhancing technologies so you can say, all right, to us as the organization who owns this data, this feels like we put data in the left side and we get predictions out the right side. And in the middle, the platform is doing all of the sort of monitoring, observability, and data protection at a technology level to the greatest extent possible. And that doesn't exist yet. I think that would be extraordinarily valuable. And frankly, sort of where we see this going, it doesn't really make sense for every organization on Earth to have to pick their own little collection of PETs sort of randomly based on what questions come up without having the overarching vision of how these things work together to protect data through its full life cycle. So full life cycle data protection technology, I think, is something that is coming up. It's going to be important both in traditional analytics and machine learning workflows and these like sort of next generation large language model, foundation model workflows.
Really good point, Ben. Thank you very much. Thanks for everything. Thank you.
Yeah, thank you for having me.
Okay, that's all for today. Please follow the Masters of Privacy channel on LinkedIn if you want to find some interview transcripts, cheat sheets, and other useful resources and surprises every now and then. On top of that, episode notes and other feeds are available on mastersofprivacy.com. Thank you for listening.